Hello guys, and welcome back to the second part for our ARM processor stuff that we're going to be doing. This will be the coding section of this. Sorry it's taking me a while to get this movie out. It's just been really busy. I've been having to work on a lot of different projects, and so just getting settled down a little bit to be able to do another video. So hopefully we'll be able to get some more out soonly for you guys. But for right now, what we're going to do is we're going to do basically like another Blink project. That's what we're doing, but with this little board, this little development board that I talked about last time. So if you haven't watched the last video, check it out. It explains about this board and kind of the hardware behind it and how it's going to work and how we're going to mess with it. So without any further ado, we're going to go ahead and get to it. What I went ahead and downloaded was downloaded Keil, or Keil, or however you want to pronounce it, but I pronounce it Keil. Where you can get this actually is you can get this from Keil.com. Grab that for you guys. You come here and you can look at software downloads, product downloads, and you can check this, the MDK-ARM. Check that out. And I've got a link that's down in the description of this video that'll take you to the right places and everything. But just to give you an overview, but it's this, I've heard it pronounced Keil, is what I've heard it be pronounced, but this one I'm looking at, this is one that you can get. This isn't one of the free GNU ones. There's lots of GNU versions out there. For those of you that don't know what that is, that's GNU is basically the free version one. It's like a Linux based one. There's actually some that work for Windows. They're the tool chain for Windows. A lot of them work in a Linux environment, and I suggest if you haven't played with Linux to give it a shot. Try either Fedora or Ubuntu or some different versions to play around with Linux. I'm going to play with this just because this was the kind of easiest to get started, but for those of you that may want to really get involved in developing the ARM stuff and don't want to have to pay the hefty price tag, because Keil comes with a hefty price tag. It's pretty expensive software. So those of you that want to be able to do a little more in-depth things, because I think you can download from here. You can download a trial of it, but I think it's limited to how much compiling it'll do. It'll only compile like I think 2000K or something like that, 2000K words or something like that, and so it limits you to how much you can mess with, just so they can give you a taste of what their software is basically. And it's a full IDE, whereas I'm probably in later videos, once I kind of get them figured out, I have to admit that it's pretty complex to get the linker scripts and things written properly for the GNU versions, and so once you get that put together, you can use some of the other IDEs like Eclipse or NetBeans or something like that, and then you can couple the tool chains with that and basically gain the IDE, the integrated development environment that you need to start building full-fledged embedded systems and programs and things for full-fledged images for the ARM processor that we're going to be dealing with. So maybe in later videos I'll get the GNU going. Once I get that working and operational on my machine, then I'll kind of show you guys how to do it. Again, like I say, I'm fairly new to ARM, so we're all just kind of learning together, so feel free to make comments, point out things that I might be making a mistake on or something. I'm totally open to stuff, because like I said, I'm learning like you guys are too, so we'll just kind of tackle this all together. But anyway, anytime I figure out anything or figure out some cool stuff, I'm definitely going to post videos on it. So anyway, this is kind of where you get the software I'm going to be showing you for this time, and maybe some multiple times afterwards, just to show you some of the basic features and functions of the ARM processor family, particularly this F0 processor that I showed you guys. So anyway, let's get that out of the way. When you open Keil, you're going to get this. It's called like MicroVision or MicroVision for whatever. Like I was going to try to do the about thing, but anyway, you're going to get this, and this is the tool chain you'll get. Once you open it, then to create a new project, it's fairly simple. We're going to go up to Project. We're going to say New MicroVision Project. I just created a new folder, and we'll just call this New Blink. That's what we'll call it, let's say. And now you get to choose your CPU. So now we're using one from ST Microelectronics. So we scroll down here, find ST Microelectronics, okay, expand that out, and now we are using the STM STM32F051R8, I believe. And look at my little deal real quick just to make absolutely sure. Yes, it's the R8. So we're going to find the R8 down here, STM32F051R8. That is our core that we are using. And then we're going to hit OK. It's going to ask you if it wants to copy the startup file. Yes, you do want to copy that startup file. So yes. And now over here in our project window, you can expand this out. And in our source file group, there's that file that they were talking about, the startup file. So now, another startup file that you need is a startup configuration file, which basically sets up your internal clock. If you're using an internal clock, it sets it up for external. It's basically kind of like in the PIC macros, at least from what I can gather. In the PIC macros, have basically their config registers and everything. You know, you set up with that config function or the fuses function or whatever, depending on what compiler you're using. This has basically, you write a C file to set all of this up. It's all encased in the C file. Now, those C files can get fairly complicated for setting up all the startup functions and everything, but I have found something that is really neat, that's really unique, that actually is kind of hard to find. It took me a little bit to find it, but ST Microelectronics has a zip file that's a clock configuration template file, and basically you get this really cool Excel file that will set up all of your clock stuff for you, and it'll actually output the C file for you. So it'll actually, you can pick and choose what kind of clocking you want with different types of, whether you want to use internal, external, all different types of configurations, and it will build the .c file to go with your project. And I'm going to show that to you right now. And I also will have a link, or actually, I take it back. I will take, and what I will do, since that was so difficult for me to find, I will take the zip file that has all this stuff in it, and I will post it in the project folder under my code link. You know, if you go to my channel, those of you who haven't been to my channel, if you go to my channel, there's on the, I believe, right-hand side, they've kind of revamped YouTube, so I don't know, I'm pretty sure, I think it's on the right-hand side still, but there's a link called Project Code. If you click on that, that'll take you to a MediaFire site that has every lesson that I've done. It has the code and everything from it. So if for some reason, you know, if you are unable to click high resolution on these videos, because if you choose high resolution, it won't be blurry, the text won't be blurry. But if you're unable to choose it, your internet connection doesn't support it or something like that, you can always go download the code from there. I will always post my code from my sites on there, and so I will always have that code up there. So what I'll do for this lesson, though, when I post this lesson zip file or whatever to download, I'll go ahead and add the zip inside there that has this this cool little Excel deal that generates your C code for you. So without any further ado, I'm going to go ahead and show that to you. It's right here. When you open it up, you've got this little configuration wizard. I don't know, maybe I can blow this up a little bigger. There we go, man. Maybe a little more. Oh, get out of the way. There we go. This program uses macros to make it work, so you have to have macros enabled, and that's what this kind of disclaimer is down here. And it tells you, depending on what version of Excel you're using, how to do that. Just for instance, I'll show you with this one. If you go up to your little ribbon thing, go down to Excel Options, you go to the Trust Center, and then click on Trust Center Settings. There'll be a place where it says macro settings. You just say enable all macros. Now, for those of you that may want to keep your macros disabled, I think it says disable macros with notification is the default. Just change it to this every time that you run this, and then make sure and turn it back if you want to keep, you know, your default settings. But in order to run this, I've noticed the best way to do it, because for some reason the prompts and stuff get messed up, is just click enable all and then click OK on all of that. Now that should enable this to work like it's supposed to. It has two different configuration modes. It's got Wizard and Expert. The Expert mode allows you to choose everything pretty much. You can set up whatever you want, whereas I kind of like, at least now since I'm a beginner, messing with just the Wizard part of it, because if you leave it on Wizard, you put in whatever frequency you want to run at. Put in, like, I don't know, you want to do 4 or 8, or say we want 16. and you say run, and it'll ask you if you want it to be the HSI as source clock, the ASSE as source clock, the PLL as the source clock, or whatever you want, or which you can use the internal or external is what the difference is between them. So we could say we want the PLL one, okay, and so then it chooses all that for you, and then it sets it all up basically, and it tells you there's your age clock frequency in megahertz. So basically, okay, and so basically, oh, I'm sorry, I forgot right here. This is for if you're using external. I'm sorry, HSE is for external, HSI is internal. So in this one, if we wanted an external, then we can specify from 4 to 32 megahertz an external one. Whereas we're using the internal one, so it's the internal one's already, the HSI clock is 8. It just bridges it through, and then we can also do the prescaler and scale it basically. So now if we want our external one to be 16, we can put 16 megahertz. Click run. We'll choose HSI as our internal clock, since that's the one we're wanting to use, the internal one. Hit OK, and then it basically sets up everything now. And so now it sets up all your timer. It even gives you a % error output. It's kind of cool. But let's say we wanted to do only 8 megahertz. We just change it to 8. Hit run again. We want the HSI, PLL HSI actually, and then we'll hit OK. That sets up all of our stuff, and our error looks pretty wide, so we may play with it again, do something different. I mean, it's just it's whatever you want to, however you want to do it. So you can pick there we go, and then that changes. Now our error is a little bit better, so it just changes. Hey, someone subscribed to me. Isn't that fantastic? Thank you everyone who subscribes to me. Thank you very much. That's fantastic. That's funny, I got that notification. Anyway, so I'm going to stay with we'll do 16. That's good enough for me. So let's do 16. So we've run it, we chose internal, we say okay, it sets it all up. Now here's the really cool part. If we click generate here, click on it, it says file successfully generated. Now wherever you have this, which I have it stored like right here, basically here's my Excel file that I have, it just puts it in the same folder. So there is the new file that it just generated, and then that we'll use in our system. So what I'm going to do is I am going to cut that file back to my ARM in our new folder, which is where our new blank project is. I'm going to paste it in here real quick. So paste. So I'll put that in there, that way everybody's together. Now we're going to get rid of this. We're back to Keil. And what I'm going to do is actually I'm going to create a new group. I'm going to say add group, which basically is a folder. Add a group, and I'm going to call this C. So this will be C source files, okay? So now I'm going to take and add files to C. I'm going to add this file right here. So, and there it is. Now, if you open this file up, what you'll see is basically this comment section. What it'll tell you is that the system clock is 16 megahertz. Okay, our H clock is 16 megahertz. So there's our 16 megahertz. So, and it's showing the clock source is the PLL HSI, which is fine, and it tells you everything about it. And this is basically what is going to set up all of your clock stuff, all of your clock sequence and everything. And you have to have this. So, awesome deal. Now we're going to go ahead and create a new file, and we are going to save it, and we'll call this new blink, or we'll just call this blink main. That's what we'll call it. This is our blink main, okay, and then we need to add this to our group. Okay, so now it's added, because otherwise if you don't add it over here, it won't compile right when it's ready to go. So now we need to put some code in. I already have some code that I've pre-written, and we'll go through it. I'm going to go ahead and I'm just going to paste that in. Go ahead and paste that in, and so now there we go. So now we have, oh, and then this is a funny thing. If you don't, I can show you this in a minute. If you don't add a new line like this afterwards, you'll get a warning. Don't ask me why. It'll give you a warning. So anyway, the thing we want to make sure we include, kind of like how we do the include 16F, 676.h or whatever. We want to include this STM32F0XX that takes care of the F0 family, the whole family of stuff. So you want to include that header file. That's definitely one that you want to do. Now, what all of this is. Well, first of all, what we're going to do is we're going to start a internal timer to keep track of our time, so we know when it's been, a second or 2 seconds or 3 seconds, or in my case, what I did was I did a delay function for, or in this case of this code, I did a delay function in milliseconds. So what we're going to do is we have a system tick handler. What this is this is your basically your event receiver type deal. It's your it's like your ISR. It's like your interrupt service routine. So we've got that here. So every time that the counter overflows, we're going to do something here. And in our case, we're going to increment this MS ticks. So basically, every time it overflows, which will be every millisecond it overflows, we'll get a tick. Okay, so we'll add one to it. So what we're going to do, we're going to create a function. We're going to create an inline function called delay. It's going to use an unsigned int32. Okay, that's going to be called delay ticks. Okay. And so what we're going to do here is then down here we're going to say while the millisecond ticks, okay, so these guys is less than what we're saying it delay to, then systick val is going to equal, or it's going to just sit there and loop forever. So it's going to wait. It's going to wait for it to become, for so many the milliseconds that you specify up here passes before it moves to the next line. And once it moves to the next line, the systick basically value variable, we're going to change it to 0. We're going to 0 basically the system tick out, so it's going to chug along in milliseconds and then until we reach whatever we want, and then we're going to clear it out back to 0. So then we can go, and we're also going to clear our ticks back to 0. So basically it clears out every however many milliseconds that we specify. It's going to clear it out afterwards. Okay. So now, as we move on down to the main function, we've got our SystemInit function. I've noticed that you have to put this in. You put this in to initialize all the system. That's when it goes, I believe, when it goes to this system.stm file, picks up the clock and sets up all the clock and all that stuff. Here's when we set up the systick config. Okay, so now this function, what this function will do is it will set up basically when the systick interrupts and comes in, what you're going to be doing. And where we're going to do is, actually, I've copied this code from another thing. We got to change this number, actually, since we chose a 16. If you remember, in here we chose a 16 megahertz clock, basically. So we're going to have to change up this number. This is what sets how fast it's going to go. And what it is this is it's a 24-bit down counter is what it's called. It can be configured with like a if you configure its IRQ, it'll generate periodic interrupts is what it does. And so basically that's what we want. So what it's going to be in our case is it's going to be whatever our system clock is divided by 1,000 is what it's going to be to get milliseconds. So our system clock is 16 megahertz, so that would be 16,000. See, make sure I did that right. If we have 16 by 1,000, yes, you're gonna have 16,000. That's right. It's late at night. So anyway, so we're gonna have 16,000. So that's what we're gonna do. So every 16,000 clock cycles will be a millisecond, basically. And so every 16,000, it's going to interrupt. It generates an interrupt. So, which means that it'll come to our systick handler, which is basically our interrupt, our ISR, basically our interrupt service routine, and it's going to increment. And then, of course, we're telling it that we want to increment this variable. Now, that's where this volatile comes into. Is we created this variable, we created it as volatile, so it doesn't get cleared out, and so we created this variable outside, so it's a global variable. It can be used in our main function as well in this function and in any other function. So it increments this, and that's where you set up when it interrupts. Okay, so it's basically system clock divided by 1,000. In fact, I may put that comment in here. System clock divided by, let's see, we'll go 1,000. So that's what that is. That's where you figure out this number, and that'll give us our milliseconds that we're looking for. Now, next we need to set up our GPIO clock. I have another link that's down below that is a link for oh, I can't remember what it's called. It's like understanding the STM-F0's GPIO ports or whatever, and it is a very good read. Read through that. It basically gives you a very good overview on basically how the GPIO is set up on one of these and how the registers and everything are configured. But each port will have its own GPIO clock. And I notice that says lock. That's clock. Anyway, right here. Anyway, so what you have to do is you have to enable that clock. Now, in our case, what we use is the RCC, and then it is the AHBENR of the RCC. And if you wonder where all this stuff is it is located, which will be defined in one of the in this .h file is where it's defined at. But that's basically the register. So we're selecting which GPIO clock to enable, which it's going to be less than 19. We're going to basically move this, take a 1 and then move it 19 places to the left, and then OR it in with this AHBENR register. So that way, and we're ORing it so that way, if for any chance maybe later on we want to change stuff up, we want to enable port B or port A or something like that, we'll OR that in too, and that way it doesn't mess up this one, because if you AND it in or something like that, it'll basically clear out everything but what you're putting in, so we don't want to do that. So I always just get in the habit of putting ORs. But where this 19 comes from, again, like I said, if you read that one link that's below, that understanding GPIOs and stuff, it'll give you a better understanding of where all this stuff is. And the same thing as setting your like this one, you can set pin C8 as output, because just like in microchip, these things have multiple functions on each pin, so it can be set for input, it can be set for output, it can be set for analog to digital, it can be set along to just digital, it could be it could be a bunch of different things. Now this port and this pin by default is a digital GPIO port defined, so that's why I picked this one. So I don't really have to do any other defines to configure it specifically for what we're doing, but always keep track of it. Always watch your ports, especially those ones that have multiple functions on each pin, because it could be you may have to set up special things. But anyway, so this one we're just setting it as output, and again, where to place the one and how to OR it in and everything, you can read that one file and it'll help you, or that one website, and it'll help you with that. And then we're going to create basically our infinite loop right here. And first thing we're going to do is we're use the BSRR, which is the bit set function. It's kind of like, it almost makes you think of assembly. So we're going to do the GPIO C, and we want pin 8 of that one, so that's why we have the 8, and then we have to move the 1 over 8 places, but that'll select pin 8, and that sets the register on pin 8 high, which will turn on the LED, because I don't know if in the last one, in the last video for this, I showed the hardware, and on pin 8 is where or on C8 is where the LEDs connected. So that'll do a 1. Then we're going to call our delay function, and we're going to, at least in this case, I put 100 milliseconds. You could do 1,000. You could do whatever time you want. But I did 100 millisecond delay, and then I did BRR. If you don't do BS, you do BRR. It's the same thing as like doing bit clear in assembly, if those of you would play with that. But it's basically the clear, and that turns it back off. We do the same number, and that will turn it back off. And then we'll delay for another 100, and so basically it's going to blink every 100 milliseconds. And that is basically it. Now we can go ahead and build it. I'll show you how to build it. Now, there is a way with the ST-Link. You can combine ST-Link, which is basically the programmer that is on board with this chip, with this IDE somehow, and I'm going to say somehow because I haven't really figured it out yet. So I'm sure it's going to be simple. So what I do is I just make this output a hex file, and then I use the ST-Link software that you can download from ST, and there's a link in the description for that as well. It's the ST-Link software download that is basically kind of like if you guys used the MP Labs U2 programmer, USB programmer from ME Labs, or ME Labs, not MP Labs, I'm sorry, ME Labs, the U2 programmer from that. I think I showcased that in one of my videos talking about different programmers for the microchip family. It's kind of like that. It's like a standalone little software that you can use to talk to the programmer that is on board with this discovery kit. And in fact, I can show it to you. Let me see if I can grab it. Here it is, STM32. It's this software, and you basically, it's the same thing. You basically have connect to target, disconnect from target, full chip erase, program and verify, and then you have your different settings and stuff. But basically what you do is you just pull in a hex file into this, just like we did you can do with that U2 programmer, and hit program, and it sends it all to the programmer that's on board, and everything works fine. So anyway, that's a little program that you can download. Like I said, I got the link in the description that you guys can see for right now, just because, like I said, I haven't figured out how to integrate that ST-Link functionality into this IDE yet, but once I figure that out, I'll show you guys that too. So in order to create a hex file, it does not automatically create a hex file, unlike MP Labs IDE. You have to tell it to. So where we tell it to is you go up to your project, and you're going to go down to options for file, or not file, options for, oh, we have to get out of here. Okay, you have to click on your target one, basically your top level system, and now you're going to go project, options for target one. Okay, and once you're in, this little options dialog will come up, and it is under your, let's see, now I forgot where it is. It should be under your output. There we go. It's under the output tab. And under the output tab, you'll have a checkbox that says create hex file. You're going to check that checkbox and click OK. And you do have to do that for every new project that you create. That is not a default setting for this MicroVision. You have to, whenever you create a new project, you'll have to check that if that's what you want it to do, is to create a hex file. Now we go up to our build. We're going to press build, and hopefully we don't, yep, we got 0 errors and 0 warnings. And what it did is it went ahead and wrote the hex file, and I can show you that by, let me grab the folder. Okay, here's our folder that we're in, and we've got right here, there's our hex file. And if we open it up, kind of looks kind of familiar, doesn't it? It looks kind of like the stuff we see with microchip. So there you go. So there's your hex file. That's all you need. You can grab that other program I showed you, open this up, hit program, make sure your stuff's connected, and program your chip. And that pretty much does it for our first program with ARM processors. I will probably create another video after this following up, and we'll have kind of, well, I'll show you how to actually program the device using that ST-Link software in our newly created hex file that we have. And I'll also show you kind of a physical demo of like what the board looks like, and pretty much how to connect it up. And it's actually pretty easy. It's just a USB cable, and that's pretty much it. And then I'll show you it actually functioning. We'll program it, and you'll see the light blinking. And so anyway, that does it for this video. Hope you've enjoyed it, and hope you're excited like I am for our future in playing with these ARM processors, because I really would like to play with these, see all the different functionality, and see how it's going to work for us. So anyway, that is it for this video, guys. Hope you guys continue coding and continue having fun while doing it, because that's what it's all about, is having fun. Alright guys, take care. I will see you next time.